Hey everybody, it's Miss Eisencraft back with task 2 for chapter 10 review. All right, Phoebe has this theory that older students at her high school are more likely to bring a big lunch. She takes a random sample of 80 sophomores and finds that 52 of them bring a big lunch. And then she samples her seniors, 104 of them, and reveals that 78 of them bring a big lunch. So we're going to have P1 equal the proportion of sophomores who bring a big lunch, and P2 equal the proportion of seniors who bring a big lunch. So her hypothesis is the null is there's no difference. And then this one, this is sophomores minus seniors, right? And she's suspecting that the seniors, more of them are going to bring a lunch. So that's why the alternative is that sophomores minus seniors is going to be less than 0 because she's suspecting that seniors are going to be higher. Okay, we're going to test. We know her sample is a higher percentage, but we want to know, is it significant enough to be convincing evidence that this is actually the case for the whole population? All right, we're going to use a significance level of 0.05. So it sounds like she already did this in her test statistic, meaning I'm going to kind of explain what the test statistic is. We're using proportions, so it is a normal curve, and the null is that there is no difference. So her sample did show a difference, and it was 1.48 standard deviations below 0, so over here. And we want to know what p-value is that. So again, the P1, the 52 out of the 80, and again, we did not have to do this for this problem, all of this, 52 out of 80, this is the P1 sophomores, and that was our, and P2 was 78 out of 104, just to kind of get some context of what's going on, because stats can make you cry if you don't know what's going on. And then 78 out of 104 is 0.75, right? These are her seniors. These are her sophomores, and her samples the 10% higher, right? Now it's asking, that seems significant, but in a normal sampling distribution, we're bound to get some variability. So is this significant enough to say that there truly is more seniors in the true proportion, the true proportion of seniors, like in the population, the whole school, are bringing more, or more of them are bringing big lunch than the younger kids. So to match this p-value, if you had the calculator will just give it to you, but I don't want you to forget what this means, right? You would go to this on your z-table because this is a normal curve, right? It's a z-test. So we have negative 1.48, negative 1.48 all the way here. Can't see what I was doing, I'm sorry, negative 1.48. It matches with, this is the percentile, which is our p-value. Okay. So what is her conclusion? Remember, she's going to compare her p-value, which is this, to the alpha, right? So the alpha is like, we're going to say it's significant if it is at this 0.05 level or less, and it's not. That's not to scale, but this is the 0.05, right? And so, yeah, it's not super likely that this would happen, but it's not convincing enough. It could happen in this sampling distribution. So what is Phoebe's conclusion? We would say, since P equals 0.0694, which is greater than the alpha, we also want it to be less than. It's greater than. I guess you also could say which is not less than, right? The alpha level. We fail to reject the null. We fail to reject the null. And then maybe I would say we don't have convincing evidence. that more seniors than sophomores. Are bringing a sack lunch. All right, so how do you perform this test on your calculator? So we could go to stat test. It is a proportion because it's like, do you bring a bagged lunch? Yes or no. And we have two samples. We have the sophomores and the seniors. So whenever it's a proportion, look for the word prop in your test. Okay. So to proportion z-test. Okay. Number 6. So we got stat test 6. Stat test 6. All right. Do I have them? No, I already replaced them. So we have 52 out of 80. We have 78 out of 104. Okay, and we are less than because we were subtracting seniors from sophomores. Okay, let me draw it as well. Does this match? Yes. Negative 1.48, which is what she said they got for this test statistic. And we could actually go back and do the formula, but that's a lot of calculating. And then 0.0699. So it's almost this, I don't know why this is a little bit different. Just maybe probably a little bit more accurate. It's almost a 7% chance that this could happen if the null was true. So that's not unlikely enough, right? Not past our threshold, which our significance level at 0.05. So perform the test on your calculator and make a sketch to support Phoebe's conclusion. I kind of already did, but yeah, I did up here because I wanted to describe what we were finding up here. Again, we performed the test against the idea that there was no difference. And, how likely would it be to get a sample that did have that difference? It was kind of unlikely, but not past our significance level. So we don't have convincing enough evidence to reject it. So we can't say that we can't reject the null, which says there is no difference. All right. Stop talking.